Imagine you're a seed. When you're sown in a field, you have to grow and develop into a big plant that produces a big yield. But during this time, you will face many challenges. Drought, flooding, salinity. Under these conditions, how will you be able to germinate? When you're a bit bigger, you will face nematodes, beetles, caterpillars, and all kinds of other insects that want to eat you or the plant that you're developing into. We know that seeds and plants have their own defense mechanisms. And through breeding, we are able to help the plant get more resilient against all of these challenges. But there's a different way that we can help seeds and plants, and that's through seed enhancement. Now, we are protecting seeds through plant protection products. These can be fungicides, insecticides, nematicides, anything that can help protect the plants against these challenges. By going from a foliar application through seed application, we can reduce the need of these products by about 90%. And these plant protection products, which are often chemicals, are regulated in Europe. The European Committee has set regulations for how much residues are allowed to be on seeds. These maximum residue levels are under pressure from consumers and retailers that would like to see these levels even lower. We can achieve this by using different materials. We can use microorganisms to protect our plants. Often people associate microbes, so bacteria and fungi, with diseases. They can cause disease not only in humans, but also in animals and plants. But luckily, not all of them are bad. There are so many beneficial microbes that we can use to help protect our seeds and plants. One example is a fungus, or there are several funguses out there that can attack insects. The spores of these fungi are able to penetrate the exoskeleton of insects and grow from the inside out and defeat the pest insects and protect your crops. Another way is have a microorganism fight off another microorganism. So on the left you see a fusarium, which is a soil pathogen. This fusarium attacks seeds and young plants in fields. By adding a bacillus on the plate, you can see that the growth of the fusarium is inhibited, and the fusarium wants to stay as far away as it can from that bacillus. In all of these ways, we can protect seeds and plants from these challenges. Another benefit of lots of beneficial microbes is that they can help the plants with nutrient uptake. So you will not only have the benefit of protecting them, but they will also have an enhanced growth. But how are we using this in practice? If we look at an example with corn, we can use several different seed application techniques to apply microorganisms onto the seeds. One of them is film coating. In this technique, we can use a specially designed polymer formulation to adhere components to the seed. With this technique, we can add microorganisms, nutrients, and any other additives to the seeds. This is only a thin layer and may not be suitable for all microbes. Another technique we can use is called encrustment or pelleting, in which we will create a thicker layer. You can compare it with M&Ms. If you see the peanut inside as the seed, then the chocolate around it is your encrustment or your pellet. So it's a much thicker layer, and often especially when you make a pellet, you will lose the shape of your original seed, and you will just make it round. With this encrustment, we can create extra seed space, which allows us to apply more material, but it also allows us to apply bigger materials. There are fungi out there that have spores that are 100 micrometers or 200 micrometers big, and you are not able to apply those onto seed with a thin film coat layer that will only be 1 or 2 micrometers thick. So for that, you need something bigger. When it's on the seed, of course, it's important that your microbes are still able to grow and develop and, in fact, help your seeds and your plants. So it's important that they are able to grow out of your seed treatment. So you see that the corn seeds were placed on agar, and in this case we added a trichoderma, which is a fungus that both helps with nutrient uptake, and it also helps your plants as a biofungicide. In both cases, it is able to grow out of your seed application technique, and then the most important thing is that you will be able to find it back in your root system. The great opportunity we get from applying microorganisms on seeds is that the microorganism can grow and develop with the growing seed. So if the root comes out of your seed, the microorganism can immediately colonize your root system and therefore protect your seeds from an early stage. So it's important that you're able to have the microbe come free from your seed application and penetrate your root system. So if you imagine you're a seed, how would you protect yourself?